Page 21, number 103. Read the question and then come back. Okay, let's get started. Now, you know that you're doing two different transformations in this problem. One of them really does require a graph, so make sure you have graph paper handy. Now, let's look through and see what they need us to do. So we have a triangle. First, it undergoes a reflection across the line y equals 3. Now, a reflection over any line other than the x-axis, y-axis, or the lines y equals x and y equals negative x really does require a graph to make it easier. So we're going to do that one on graph paper for sure. Then it says that the next transformation is a rotation of 180 degrees. It does not specify clockwise or counter because, well, it doesn't matter. 180 means you're going upside down. And then it says to graph and label the coordinates of A double prime, B double prime, C double prime. So you're asked to graph and label for your final answer. Now, A double prime, B double prime, C double prime means the final. It's two different transformations that happen, so 2 tick marks. Okay, so use your graph paper. Go ahead and graph A, B, and C, and we'll come back. Okay, so here I've graphed my 3 points. Now, when you reflect over the line y equals x, you have to know what that looks like. Oh, I'm sorry, not y equals x, y equals 3. You have to know what that looks like. A y equals line crosses the y-axis. Y equals lines are horizontal lines, and they cross the y-axis at whatever number it says. So in this case, since it says y equals 3, we're going to put a point at 3 on the y-axis, and we're going to make a horizontal line that passes through the y-axis at 3. You always need to see your line of reflection so that you can reflect and flip over it. Now think about where your answer should end up. If we're flipping over this line, our answer should be here somewhere. Okay? So I'm going to zoom in and I'm going to start counting from my points to my line of reflection. So let's start with A. A is 1, 2 boxes to your line of reflection. Count the same amount on the other side. 1, 2, and plot a point. This is now A prime. Next, do the same thing with B. 1, 2. So 1, 2 again. B prime. And then lastly, C. 1, 2, 3, 4, 5, 6 boxes. So again, you're going to do 6. 1, 2, 3, 4, 5, 6. Okay, so here we go. We ended up with C prime at the top. I'm going to connect my 3 points so I can see my first image. Fix that line. Okay, so this is my first image, my single prime. Now we're going to take this image and we're going to rotate it 180. No longer are you going to look at this green triangle, those original points. You're now focused exclusively on this blue triangle at the top. Now, when we rotate, you have 2 options. Rotating 180, you can either turn your paper upside down and look at the coordinates, which is the way that I love to do it, but there's also a second way of doing it, and that's using the rule for rotating 180. Okay, so pick whichever one works for you. Either turn your paper upside down and look at the new coordinates, or apply this rule that I'm going to give you now. The rule is this. You're going to take your x and y coordinate, and you're going to have them switch signs. Not switch places, switch signs. So xy becomes negative x, negative y. We're going to do that to every one of the coordinates. This is a rule that I do recommend that you memorize. It's pretty easy to rotate 180 using the rule, but it's also really easy to rotate 180 by turning your paper. Okay, so I'm going to give myself some room to work. I'm going to write down my coordinates, and I'm going to use the rule. Okay, so right now, A prime is located at negative 2, 5. So that means A double prime will have both coordinates change signs. So positive 2, negative 5. Next one, B prime. B prime is at 3, 5. So B double prime, I'm going to switch the signs. It says negative x, negative y, so switch the signs of both coordinates. So negative 3, negative 5. And lastly, C prime. C prime is right now at 0, 9. So after the rotation 180 degrees, C double prime will be at 0, because 0 doesn't change signs, negative 9. So these are all of my coordinates for my final answer. I'm going to plot it, and I'm going to see if it makes sense. Okay, so I'll make my final answer in red. Okay, 2, negative 5 is going to be right here. That's A double prime. B double prime is at negative 3, negative 5. B double prime. And C double prime is at 0, negative 9. Okay, connected my 3 points. This is my final answer. And it should look like your figure rotated upside down. Okay, like we talked about before. It should look like it went upside down. And it does. C prime was facing up. Now C double prime is facing down. It does look like it rotated 180 degrees. Okay, and now we're done. Let's move on. Number 104. Reflect the trapezoid RSTU over the line y equals x and then rotate it 90 degrees clockwise. Your ask is to graph the final image, not to state the coordinates, but to graph it. So reflecting is going to happen first. You're going to reflect over the line y equals x. That's one of the types of transformations that I recommend that you memorize the rule for. It makes things a lot easier, so we'll talk about that. After you've reflected over the line y equals x, the next thing that you're going to do with the new figure that you've just created is you're going to then rotate 90 degrees clockwise. So you're going to do a rotation of 90 degrees. I'm going to put clock. Okay, let's get started. Now, I'm going to use the rule to reflect over the line y equals x. The rule says you're going to take your x and y coordinate, and just like it states y equals x, you're going to switch places. You're going to have your y and your x values switch places. So it's going to become y, comma, x. All right. I'm going to take a moment now. I'm going to write down all 4 coordinates for R, S, T, and U. Okay, so R is located at negative 7 and up 1, 2, 3, 4, 5, 6. Negative 7, positive 6. S is located at negative 4, positive 7. T is located at negative 1, positive 5. And lastly, U is located at negative 8, positive 2. Okay, so to apply the rule, we're going to have R, S, T, and U have their x and y coordinates switch places. So negative 7, 6 will turn into R prime, which is at 6, negative 7. So all they did was they switched places. Going on to S prime. S prime is going to be at 7, negative 4. T prime, 5, negative 1. And then U prime, 2, negative 8. So the rule is really easy to memorize when you are reflecting over the line y equals x. Okay, So now I'm going to take these 4 coordinates, I'm going to plot them on my graph because I want to see, did my reflection make sense? You should do that as well. Okay, so here I've plotted my image points. So you should pause if you haven't done so yet and plot your image points. And I want to show you what the line y equals x looks like so that if you are a visual person, you understand what to do visually as well. I'm going to zoom in. I'm going to plot the line y equals x, which starts at 0, 0, and then it goes diagonally to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. Same thing in the opposite direction. It has a slope of 1. It crosses 0, 0, the origin. Okay, so your line for y equals x looks like this. So you should ask yourself, does it look like it flipped over that line? Absolutely. Now, how do you make sure? Well, you make sure that it's the same distance before and after to your line of reflection. So since this line is y equals x, I'm going to show you how, yes, it is the same distance. Now I'm going to zoom in, and I'm going to show you with t and t prime. So notice right now, t, if I count diagonally to get to my line of reflection, is 1, 2, 3 boxes away from the line of reflection. Now on the opposite side, if I count 3 again, I should end up at t prime. 1, 2, 3, and I do. This works for all of the points. I'll show you with u. Counting diagonally, 1, 2, 3, 4, 5 diagonal boxes. Same thing on the other side. 1, 2, 3, 4, 5 diagonal boxes. That's going to work for all of the points. And that's also how you would do this visually if you didn't know the rule. You would count diagonally to your line of reflection and the same amount of diagonal boxes on the other side. Okay, so now our last step in this question is to rotate this figure 90 degrees clockwise. Now let's think clockwise. That's like the hands of a clock. I'm starting here and I should go clockwise. So if that's 5 o'clock, I'm going to go to 6, 7, 8, 9. I'm going to go in this direction. I should end up somewhere in this quadrant. That's what I'm thinking about. Okay, I'm going to erase this and I'm going to show you how to do it. Okay, since we're rotating 90 degrees, there's a lot of rules for rotations. I recommend memorizing 180, but when we're talking about 90 and 270 and different directions, clockwise or counterclockwise, I do recommend you doing this visually. Now, how do you do it visually? Just like before, you're going to turn your paper 90 degrees clockwise. So it's going to take me a second to do that with my computer screen, but just know you're going to turn your paper 90 degrees clockwise, which means you're going to turn it in this direction, to the right, 1/4 of a turn. I'll be right back to show you what that looks like. Okay, so now take a look at my diagram. I've rotated it clockwise 90 degrees. So notice the arrow that was pointing to the right is now pointing down. It rotated 90 degrees clockwise. I'm going to read all of the coordinates for my red trapezoid, the one with the primes, to see where are they at now. So to show you, I'm going to start with, let's start with T. Okay, so T is in the 3rd quadrant, starting at 0, 0. Now I'm counting to the left 1 box, and then down 1, 2, 3, 4, 5 boxes down. So that means that my coordinate is at -1, -1, 2, 3, 4, 5. So T prime, or T double prime, is at -1, -5. Same thing with U double prime. Starting at 0, 0, I'm going to count to the left. 1, 2, 3, 4, 5, 6, 7, 8 boxes to the left. So that's -8. Down 1, 2. So it's at -2. R prime. Counting to the left. 1, 2, 3, 4, 5, 6, 7 boxes. So it's -7. Down 1, 2, 3, 4, 5, 6. -7, -6. And lastly, S double prime. Starting at 0, 0, counting to the left, so it's going to be negative. -1, 2, 3, 4. So -4 down 1, 2, 3, 4, 5, 6, 7 boxes down. So -4, -7. Your final answer should look exactly the way that this red trapezoid looks right now. In the bottom left corner, R prime all the way in the bottom left, and all those other coordinates, wherever they appear right now, that is your final answer. So I'm going to go ahead and graph that on my original graph before I turned it, and I'm going to plot all of these coordinates I just came up with. And my diagram should look the way that red diagram looks right now. So turn your paper back and go ahead and plot all 4 of those coordinates. Okay, so I went to my graph facing the normal direction, plotted my points that I came up with, and now my green trapezoid on the bottom left looks like the red one did when I had my paper turned. So I'm happy with this answer. My final answer is none of the other graphs except for the green one with the double primes. Okay, let's move on. Number 105. Write the algebraic description for the transformation that maps all of those points, K, O, and L, onto their image points, K prime, O prime, L prime. Now, writing an algebraic description means you're going to write something that looks like this. X comma Y becomes, and then whatever happens to those coordinates. Now, the best way to figure out just from coordinates what happened is to first visualize it and figure out, is this a translation, a rotation, a reflection, a dilation? Like, what is it that actually happened? And the best way to do that is by graphing it and looking at it. So we're going to do that now. Pause the video, plot your points before and after, and then we'll talk about it. Okay, so we graphed the before and after. The green one is the pre-image. The purple one is the image. Now, it's pretty clear that there was a dilation that happened here. So we need to think about, well, what is the algebraic description for a dilation? And any algebraic description for a dilation should look like this. X comma Y becomes K times X, K times Y. Because what you're doing is not only is growing the figure, you're also multiplying each individual coordinate by your scale factor, your K value. So the only thing that you have to figure out is K. So our goal right now is to get K. Now you always get K, your scale factor, whenever something grows or shrinks, by doing this little fraction right here. New over old. We could talk about the new and old lengths. We can talk about the new and old distances to the center of dilation. But if you have coordinates and you do know that you need to come up with K, the easiest way is to use the coordinates. So let's take a look. I can pick any of the coordinates. Now, strategically, I'm not going to pick O. Because if I pick O, I have a 0 in there, and that's not going to help me. But I could use anything else. So let me use L. So L becomes L prime. So the new one is L prime. So we're going to do L prime divided by L. L prime is at 6, 2. L is at 3, 1. So we're going to go ahead and divide. X's and Y's should give you the same scale factor. So 6 divided by 3, that equals 2. Let's check with the Y values. 2 divided by 1, that also gives you 2. That's not a coincidence. If you have a dilation centered at 0, 0, which is very important, if it's centered at 0, 0, you can write your algebraic description by figuring out K from the coordinates, new over old. And they will all get you the same scale factor. If all of them get you a different scale factor and you know it was a dilation, that means it wasn't centered at 0, 0. It may have been centered at some other point. But if it's centered at 0, 0, you can always use the coordinates. So my final answer is going to use these 2's as my K values. So final answer, XY becomes 2 times the x value, 2 times the y value. All dilations require multiplication. So if you see in the future that you have a rule, an algebraic description that shows you multiplication, that means a dilation happened. If it's larger than 1, it'll grow. So if your k value is larger than 1, it's going to be a grow. If your k value is between 0 and 1, so 0.5, 2/3, something like that, it's going to shrink, and your new figure will be smaller. In this case, our k value was 2, and our diagram clearly shows that our new image is way bigger than our original. Okay, let's move on. Number 106. Read it, come back. Okay, so they're telling you that you have a point called A. It's going to turn into A prime through a transformation. The transformation is listed here. Now, if you notice that there's addition and subtraction, this transformation is a translation, a slide. Now, A became A prime because of this algebraic description, x minus 2, y plus 5. Now, we know that means that it moved left 2 and up 5 in order to get to A prime. They also tell us coordinates for A prime for -7. What they want are the coordinates of your pre-image A. Okay, so they want you to work backwards. They want you to think about, well, what is A if you subtract 2 from x, add 5 to y, and get 4 -7? Now, to come up with that, when you're working backwards to try and get your original figure, what we're going to do is we're going to take these movements of -2 and 5, and we're going to reverse them. So to reverse them, you're going to add 2. Instead of subtract 2, you're going to add the 2 back. Instead of adding 5, you're going to subtract the 5 back to come up with your answer. So 4 plus 2 is 6. -7 minus 5 is -12. That's going to be your original point before it became A prime. Now let's think about whether or not that makes sense. I'm going to put 6 -12 right here. You can grab a piece of graph paper and do this visually and see, do you end up at 4 -7? Or we're going to take a look. If I had 6 and I subtracted 2, did I get 4? Absolutely. If I had -12 and I add 5, do I get to -7? Absolutely. Okay, it all kind of makes sense. So our pre-image coordinate is going to be 6 -2 for A. Okay, let's move on. Number 107. Read the question, then come back. Okay, so 2 different things happened here. First, they say that you have a point called B. And B turns into B prime, or maps onto B prime, because of a reflection in the x-axis. That's the first thing that happened. So I'm going to put R, x-axis. Okay, and then B maps onto B double prime. Okay, so now we have a second transformation through a translation of T -2, 3. That's the same thing as saying x minus 2, y plus 3. And then it turns into B prime. They're telling you the image B double prime is the coordinate -5, 9. So I'm going to put -5, 9 into my little visual here. And now it says, what are the coordinates of pre-image B? They want you to go all the way back to B. Your goal is to get this coordinate. All right, so let's start undoing the transformations that took place to get back to B. So first things first, they did a translation, -2 plus 3 to B prime in order to get to B double prime. So let's start working backwards to get back to B prime. To undo a translation where you subtracted 2 and you added 3, we're going to do the opposite. We're going to add the 2 back in. we're going to subtract the 3 that was added. So negative 5 plus 2 is negative 3. 9 minus 3 is 6. Okay, so that gets us back to B prime. We're now at negative 3, 6. But now we have to get back to B. So how did B become B prime? Through a reflection in the x-axis. Now you can memorize the rule, or you can do this one visually. I'm going to draw a little sketch with you to show you that you could do this visually, or you can actually grab a piece of graph paper. So here's my sketch. This is my x and y axis. My point B prime is at negative 3, 6. So I'm going to imagine it's like right around here, B prime. Now to get to B prime, B was reflected across the x-axis. So if I want to reflect it back across the x-axis to get back to B, think about what that's going to look like. B prime is going to flip back over the x-axis. So B should be down here somewhere. Now if B prime is at negative 3, 6, the only thing that would have changed is it goes from below the x-axis to above the x-axis. It doesn't move left and right, so I should still have a negative 3 coordinate for B, the original point. The only thing that changes when you reflect across the x-axis is your y value. So here it would have been negative 6, and then the person would have counted up 6 boxes, gotten to the line of reflection, counted up 6 again, and they get to a positive 6. So your original point had to be negative 3, negative 6. And then, if we think through this again, negative 3, negative 6 turns into B prime after it's reflected. And then B prime is going to translate left 2 and up 3 and end up here at negative 5, 9. But our final answer is the original point, negative 3, negative 6. Let's write that in. Negative 3, negative 6. Graph paper would have been very helpful to undo the reflection over the x-axis, which changes the sign of your y value. Okay, so we are done with this page, 21. Let's keep it moving.